Here's another problem that Cortaggio sent me, and like the other two, this is quite interesting. Although I think you'll start to see a pattern forming in how these are solved, and that's the whole point, not just to show you neat problems, but also to give you an intuition of how to solve it. So what does it say? It says Alice is 100 meters from Bill, and Bill is 300 meters away from Chelsea. Maybe this is a bit of a Clintonian reference, but who knows? Or maybe they just wanted people with starting names A, B, and C. So let's draw that out. So Alice is 100 meters from Bill. All right. Alice is 100 meters from Bill. And actually, he drew a little diagram. So we know that also Chelsea is to the right of Bill. So let's see. It's the diagram he sent me looks like this. So you have Alice, and then you have 100 meters away, you have Bill, and then 300 meters to the right of that, you have Chelsea. This distance right here is 100 meters, and then this distance right there is 300 meters. And the problem tells us they are all facing east and are standing on the same line. Fair enough. So let's say that's east. So they're all facing in that direction, standing in the same line. They all travel to the east at constant speeds. Okay, but they don't say that they're all traveling at the same speed. Their each individual speed is constant. So this could be velocity of Alice, lowercase a, velocity of Bill, and then this is the velocity of Chelsea. All right, they all travel to the east at constant speeds. In 6 minutes, Alice overtakes Bill. So what has to happen? Let me do this in another color and write down what that equation would look like. So I'll do it in green. In 6 minutes, Alice overtakes Bill. So this tells us the distance that Alice travels in 6 minutes. So what's the distance that Alice travels in 6 minutes? It would be the velocity of Alice times 6. And she overtakes Bill. So that means she goes 100 meters more than Bill went. Well, so that means she went 100 meters plus the distance that Bill went in that 6 minutes. And the distance that Bill went in 6 minutes is velocity of Bill times 6, right? This tells us in 6 minutes, Alice went 100 meters more than however far Bill went in 6 minutes. That's that equation there. We got it from this information. And then the next thing this problem tells us, in another 6 minutes, Alice overtakes Chelsea. So from the beginning of our time, it essentially takes 12 minutes, right? 6 minutes to overtake Bill, and then another 6 minutes to overtake Chelsea. So 12 minutes to overtake Chelsea. So we could write that as the distance that Alice travels in 12 minutes is equal to, well, if she has to overtake Chelsea, that means she made up 400 meters of distance, so that she traveled 400 more meters. So the distance that Alice travels is going to be 400 meters more than the distance that Chelsea travels in 12 minutes. And remember, distance is just equal to rate times time, right? So in 12 minutes, this is how far Chelsea travels. That's a C. And this is how far Alice travels, and she's going to travel 400 meters more. Okay, that's what those two equations tell us. And what is their question? They're asking us, how many minutes did it take Bill to overtake Chelsea? How many minutes did it take Bill to overtake Chelsea? All right, so let's say this question, we want to know time in minutes. Time, how long does it take Bill to overtake Chelsea? So let's say we know that it's time t. So that tells us that the velocity of Bill times this time is going to be equal to, for him to overtake Chelsea, he has to travel 300 meters more than her in that same amount of time. So he has to go 300 meters more than how far Chelsea travels in that time. So that's what this is. And then we essentially are just trying to solve for this time. We want to be able to solve for this. Let's solve this equation. Remember, all of these equations really have the same form. In order for this person to overtake this person in 6 minutes, that means in 6 minutes, she would have to travel 100 meters more than him. In 12 minutes, she would have to travel 400 meters more than Chelsea. And then in t minutes, and that's what we're going to have to solve the problem for, B is going to have to travel 300 meters more than Chelsea right there. And we need to solve for t. So let's just solve for t. So what do you get? You get VBT minus VCT is equal to 300. I just subtracted Chelsea's velocity times time from both sides of this equation. We can factor out the time, so let's do that. So you get VB minus VC times time, right? I just factoring out the time is equal to 300. Or time is equal to 300 over VB minus VC. So if we could somehow figure out what this is equal to, then we would have solved our problem. Let's see if we can use the other information. So hopefully, let's see if we solve for VB here and solve for VC here, hopefully the VAs will cancel out, and I suspect they will, otherwise this problem would not be solvable. So let's do that. Let's rewrite this equation up here. Let's solve for VB, for Bill's velocity. So if we divide both sides by 6, well, let's subtract 100 from both sides. So you have Bill's velocity times 6, that's just that, is equal to 6 times Alice's velocity minus 100. All I did is I subtracted 100 from both sides of this equation, and I swapped the sides. Divide both sides by 6, you get the velocity of Bill is equal to the velocity of Alice minus 100 over 6. 100 over 6 or 50 over 3. I'll just keep it as 100 over 6. Fair enough. Now let's see if we can do the same thing with this equation. So we get, see if we subtract 400 from both sides, we get 12 times Chelsea's velocity. 12 times Chelsea's velocity is equal to 12 times Alice's velocity minus 400. Divide both sides of this equation by 12. You get Chelsea's velocity is equal to Alice's velocity minus 400 over 12. All right. So let's see if we could substitute this back in for VB and substitute this back in for VC, and hopefully the VAs cancel out. It already looks like they should. So the time that it takes for Bill to overtake Chelsea, remember that's what T was. It's always good to remind yourself what this whole problem was about to begin with, is equal to 300 over VB. Well, instead of VB, let's write this. VA, the velocity of Alice, minus 100 over 6, minus VC. So minus this right here, minus VA minus 400 over 12. This should simplify to T. I'll just arbitrarily switch colors. T is equal to 300 over VA minus, what's 100 over 6? 100 over 6 is the same thing as 50 over 3. Distribute the minus sign. Minus VA, we can already see these are going to cancel out. Minus times a minus, plus 400 over 12 is the same thing as 200 over 6 or 100 over 3, right? Plus 100 over 3. These two cancel out, VA minus VA. So then we're left with T is equal to 300 over 100 over 3 minus 50 over 3, right? Or I could say minus 50 over 3 plus 100 over 3. But either way, minus 50 over 3 plus 100 over 3 is just 50 over 3. Right? Did I do that right? If I divide the top and the bottom by 4, I get this. And then, sure, this is 100 over 3, and then 50 over 3. And so when you divide by a fraction, that's the same thing as multiplying by its inverse. 300 times 3 over 50 is over 1. And then we can cancel out some terms, so we don't have to multiply big numbers. So if we divide the top and the bottom by 50, that becomes 1. This becomes 6. And then we're left with T is equal to 6 times 3 over 1, which is 18. And all the time units we were working with the whole time were in minutes. And we're done. That was a little hairier than the other two, but notice we were able to solve it by just algebraically writing down the information that they actually gave us in the problem and just seeing what we had to solve for and then substituting back in, and then miraculously things canceled out. And in general, if you're given a nice problem like this, you can normally just, march forward knowing that if you do things correctly, probably nice things will happen and terms will cancel out. But I thought you would find that interesting, and once again, thanks to Cortaggio for that problem.